on this at the end of last week. This is what's called the resistance equation. Sometimes you may have come across this formula before in relation to something called Ohm's law. There is a formula triangle. Have you come across formula triangles before? Associated with this. If I draw something like this, this is the formula triangle for this formula. Now, formula triangle are formulae which we use both at level 2 and level 3 to make it very easy and very quick to rearrange a formula. The idea is if you want to calculate something, you cover it up on the formula triangle, and what remains is how to do the calculation. So, if I want to work out resistance, I cover up over R, and it tells me R is V divided by I. If I want to work out what the current is, if I let's add the voltage and add the resistance, I can actually work out what the current is. In fact, if I'm given any two of these, I can work out the other one. And all you do is you cover up that other one, that one you want to work out. So if I want to work out current, I cover up I. I is a symbol we use for current. V and R are very obvious, voltage and resistance. I is current. If I'm given the voltage and the resistance, I can work out the current by covering up I, which is voltage divided by resistance. And the formula that many people may have come across before is V is equal to I times R. If I cover up V, it tells me that V is I times R. So in fact, if you're given any two of these, you can work out the other simply by covering up that other one, the one you want to work out. The formula we're using today, or the variation, or the way we've arranged this today to allow us to do the calculations of resistance, is resistance is voltage divided by current. So what I got you to do towards the end of last week, and we didn't quite look at some figures, was calculate the resistance of the lamp at 2 voltages, or at least at 1 voltage, and see what happens as maybe you increase the voltage. Well, in fact, we're going to go a little bit further today. We're going to do a formal practical in respect to that. So the idea is that you're going to determine the resistance of the lamp or resistor for various voltages. Now, the aim is to investigate how resistance varies in the lamp or resistor, and we're going to do that by seeing how, by adjusting the voltage, the resistance varies. Now, for those of you who have the auto-trip power supplies, they're the blue boxes that look like this. In fact, 5 groups have got this. It's very easy. Your practical essentially is you're going to turn it right down to the smallest value. You're going to turn the power supply on. You're going to take a measurement of voltage and current. You're then going to increase it by 1 step on the power supply. You're going to take another measurement of voltage and current, and so on, all the way up to the top value, and you'll then end up with 1, 2, 3, 4, 5, 6, 7, 8 values of voltage and current. Now for each of those you can work out the resistance, and what I expect you to be able to do, or certainly think about doing before you start doing the practical, is what table will be used for recording those results. So we've already used a table for density measurements practical. We didn't do one for the electrostatics. This week I'm asking you to record voltage and current. So think about how you're going to arrange the table to record voltage and current, and also calculate resistance. We go back to the density measurements practical. We measured height, width, depth, and then mass, and then we calculated density. That's one of the methods. You need to do a similar thing this week for the 2 things you're going to measure, voltage and current, and then an additional, I think you can guess what I'm hinting towards here. You might have columns, a column for voltage, a column for current, a column for resistance. You're initially going to take some measurements of voltage and current, and then you're going to calculate resistance later on. So I'd like to see a suitably labelled table in your results section. You can do this in pencil, but remember I do expect you to fill this in to some extent, and you're then going to use this later on to word process a write-up for this experiment. Okay, now some of the information is there. You've got the aim, introduction. I'll talk about that later, and we'll talk about how it relates to this practical, but you're asked to define voltage, current and resistance. So I expect, because you're using those values in the practical, so I expect it, find that information in the introduction when you do this write-up properly later on. Apparatus, make a note of any apparatus you use here, include a circuit diagram in your write-up. Since that's the circuit we set up, that's going to be one of your circuit diagrams. There's actually another circuit we're going to set up because we're investigating the resistance of a lamp and a resistor. So initially this is the circuit you've got to set up. Later on we're going to replace this lamp with this resistor, and that's the second circuit. Now you can either have 2 circuits or you can have an explanation that essentially says that, or states that. So I've made this on iLearn, available on iLearn. If you want to, you can. There is a way of copying and pasting this. You could just press print screen. If you press print screen, that will give you a bitmap image which you can paste into Microsoft Word, and then you can crop the sides and end up with just this diagram. There's various methods you can use. You can certainly use this. I don't mind. You don't need to recreate or redraw a circuit. You can use this circuit diagram in your write-up. Okay, so that's aim, introduction, apparatus. The circuit diagram is essentially the apparatus list. It tells you what you need. There's a power supply, connecting leads, a lamp, an ammeter, voltmeter, and that circuit diagram shows how they're set up. Method, you'll need to think about what method you use. Certainly, one of the first things to state in your practical is that you set up the circuit as shown in the diagram. So that'd be the first sentence maybe to say when you're describing the method. Now, method, apparatus, introduction, you can do later. What I do want you to do today, now, when we start the practical, is use the space in the results section to record your results. You can do this in pencil. This is really just for, remember, this is not something I'm going to look at and mark. This is going to help you do the write-up later on. So you can write whatever you like on it, as long as it's going to help you. It's relevant to physics. You know, I don't want you sort of doing a crossword puzzle or something. Not relevant to physics on it. That would be not something I really want to see. But you're going to use this to help you do the write-up. What I'll do later on is I'll give you advice on how we can process the results further, and also what's for the conclusion. And in fact, I'll give you some further advice about the introduction, because there's a mention of Ohm's law there, and I want to tie that into the practical. Okay, so the practical you're going to do is very simple. For those of you with the auto-strip power supplies, you're going to turn the voltage right down. You're then going to measure the voltage and current using your voltmeter and ammeter. Obviously, the voltmeter is the one with V on, ammeter has A on it. It's really simply the case of writing down numbers. You'll probably find you do this practical in 5-10 minutes. It's very quick practical. The group at the back who has it's an older power supply, but it's actually superior in many ways, has a series of U connectors. You know how to adjust those. So if you start at 1, then go up to 2, then up to 3, all the way up there. Just increment it. Okay. Any questions about the practical? Okay, be careful, the lamp does get hot. Once you finish with the lamp, let me know and I'll bring the resistor you're going to use. We're going to use what's called a variable resistor. You can actually vary it, but we're not going to vary it today. We're using this big bulky resistor because it's safer than using small ones. Small ones actually get very hot, so we're going to use this. We're treating this as a resistor. A resistor is a component you put in the electrical circuit. You might guess what it's used for. With a name like resistor, it obviously there's something about it to do with the resistance it has, which is different to a lamp. A lamp you'll find that maybe the resistance doesn't remain constant, but a resistor you might be able to deduce or guess that maybe the resistance remains constant. But we'll see that when we look at the results later on. Okay, so you've got your circuit set up. I've asked you, or suggested to you, hint, that you should draw a results table in the results section and record down the results as you go through the practical. You need to make measurements of voltage and current for your lamp initially, and then once you finish your lamp, raise your hand, I'll come across, I'll swap it for a resistor, and then you're going to repeat the experiment for the resistor. Okay, I'll let you get on with it. Any questions, give me a shout and I'll come over.